Good morning, children. In the last class, we had done irrational numbers. We had compared rational and irrational, the decimal form of rational numbers and the decimal form of irrational number. And we had seen the different cases of rational and irrational number. The first case is rational number is p upon q, q not equal to 0. And in the decimal form of rational numbers, we had seen they were non-terminating and recurring, one-time non. In irrational numbers decimal form, how they were? Non-terminating, non-recurring, 2 times non. Okay, and we had seen rational number, one more type, whose square root, cube root, fourth root we can remove, gives you a perfect answer. Okay, you can remove the root sign. And in the irrational number, that case was we cannot remove cube root of 5, we cannot remove it. Root of 4, we can remove it, so it's a rational number. If we can't remove this thing, it does not give you an answer, that is called a irrational number. Okay, so now you have done a worksheet also based on that. Now let us continue. Today we are going to do a special type of irrational number. Okay, so let me write down that special type. Okay, what do you feel? What is this? It is, how is it read as? You all have done it last year. It is read as nth root of a. Nth root of a. Now this nth root of a is called a surd. Okay. So we will see when it is called a surd. First we will see the parts of a surd. Later on we will see why it is a surd, why it is called a surd, what are the conditions for it to be a surd. So first let us recognize the parts. Nth root of a is called a surd. Okay, now the inside, you can you see this a? A is called, it has got a special name, and that name is radicand. And this root sign has got a name, radical sign. And can you see inside this root sign, can you see this n? This is called the order of the surd. Okay, so you have to learn the parts of the surd. What are the parts of surd? Nth root of a is called a surd. We will see when it is called a surd slowly in the course of time. Now we are going to study the parts of surd first. So this inside the root sign, can you see this a? This is called the radicand. Remember this name, radicand. And this root sign is called the radical sign. And you can see inside this basket type, this square root, this n. N is called the order of the surd. So these three are the parts of the surd: the radicand, the radical sign, and the order. Okay. So you will have to pause the video and copy this. The parts of a surd. First you copy this nth root of a, then you copy this parts of a surd. Okay. Now we shall continue. Now let us see what are the conditions for nth root of a to be a surd. Is called a surd. So we are seeing when it is called a surd. If it satisfies the following conditions. What are the conditions? Let us see. The radicand a should be a, the radicand, we had seen the inside one is called a radicand. The radicand a should be a positive rational number. I am writing in short form. Radicand a. This is the radicand a. It should be a positive rational number. Now you know that what are rational numbers. Every integer is a rational number, and it can p upon q, that is a rational number. So radicand a should be a positive rational number. Next condition, nth root of a should be an irrational number. You know how the set of irrational number is symbol of that q dash, the set of irrational number, q complement means not there in q but there in the set of real numbers, it's q complement. So nth root of a should be an irrational number. What do we mean by that? Nth root of a, it should not be, we give you a value, you cannot remove the root sign, okay, so that is called an irrational number. You already have done that worksheet. Third condition is the order n should belong to natural numbers. You know, capital N means natural number. This order n which is there inside this basket, okay, I call this a basket. So n is inside the basket. So this n should belong to natural numbers and it should be greater than or equal to 2. Okay, it should be greater than or equal to 2. When these three conditions are satisfied, then only we can call nth root of a to be a surd. So what are the three conditions? This radicand a should be a positive rational number. Nth root of a should be an irrational number. And order n belongs to natural numbers, n greater than or equal to 2. Copy this and study it by heart because you should know when nth root of a is called a surd. We'll do an exercise, then it will be more clear. So when is nth root of a called a surd? The inside one, this is called the radicand. Radicand a should be a positive rational number. Nth root of a should be an irrational number and order n belongs to natural number. Natural numbers start from 1 but your n should be greater than or equal to 2. Clear? Okay. So now let us go to the next. So now you take out, we'll do sums based on this, how to recognize a surd and how to recognize its orders, identifying the surd. So take out practice set 2.3. Page number 30. The first sum. State the order of the surds given below. The first one is cube root of 7. Okay, I will make 2 columns for easy this thing. I will make 2 columns. Here I will write down the surds and here I will write down the order. Okay. So the first one is cube root of 7. Come on, recognize the order. Order is the one which is inside this basket. I told you, looks like a basket. So this one. So this is the order. What is the order? 3. Second one. 5 root 12. What is the order? Okay, here you have to be little this thing. 5 is outside. It's a rational number. It is outside. It's not inside the basket. So inside the basket there is nothing. So this is square root. So what is the order? 2. Third one. 4th root of 10. Come on, tell me what is the order? Yes, correct. You have identified it correctly. Inside the basket, 4. Fourth one. Root 39. What is the order? There is nothing mentioned, so it means the square root. Square means 2. The order is 2. The last one, 5th one, cube root of 18. What is the order? What is there inside this basket? 3. So, order is 3. Clear? How to find the order? You have to check inside this basket. Okay, if it is outside, this is not the order. Here the order is. Here the order is this thing. It is hidden. It's square root. So 2. And here also the order is 2. And the remaining it is clear when it is inside. When it's outside, it is a rational number. It's not a order. Okay. So now we go to the next concept. Write it down in your notebook. Okay. Now we go to the next one, second one in your practice set 2.3. State which of the following are surds, justify. So the first one, cube root of 51. Now we have to find out whether this is a surd. So what are our conditions for a surd? We had seen, we had written it down. The radicand should be a positive rational number. Is this a positive rational number 51? Yes, 51 comes in the number line. Every integer is a rational number and the number line denotes the integers. No? So 51 is a positive rational number. So first we will check whether the first condition is correct. Okay. So let me write down the conditions over here. For nth root of a is a surd if it satisfies the following condition. A belongs to positive rational number. I am just writing in short form. Then nth root of a belongs to irrational number. Okay, a set of irrational numbers. And third, order n belongs to natural number greater than equal to 2. So let us see if it satisfies this three conditions. So first is we have to see a is a positive rational number. 51, yes, it's a positive rational number. So the first condition is satisfied. Now look at the second condition. Nth root of a belongs to cube complement, that is irrational number. Now cube root of 51, now let us find the factors of 51. What are the factors of 51, which is the smallest number, which goes 3. 3 goes how much in 51? 17. And 17 ones are 3 into 17. So there are no powers of 3 that you can remove it out. So nothing, it will not come out. That means this cube root of 51 is an irrational number because it cannot be removed. The root sign cannot be removed. And the order 3, does it belong to natural number greater than equal to 2? Yes, order is 3 and it is greater than equal to 2. So now let us justify it properly. So we have understood that it is a surd. It is satisfying all the three conditions. So we will write down now, cube root of 51 is a surd. Because, the sign means because. First, 51 is a positive rational number. This is in the working column. 51 is a positive rational number. Second, cube root of 51 is an irrational number. And the last, order 3 is a natural number. Greater than 2. Okay. So now it's satisfying the three conditions. Therefore, it is a surd. Understood? Copy it. Second one, cube root of 16. Fourth root of 16. Second one is fourth root of 16. Okay. So before we go, we can see that 16 is a positive rational number. The first condition is satisfied. The first condition is satisfied. Now we have to find out second condition is satisfied or not. Whether it is this nth root or fourth root of 16 is an irrational number. For that purpose, first we will break it up into factors like last sum we did. What are the factors of 16? 2 8s are, 2 4s are, 2 2s are, 2 1s are. So how many 2s are there? 4 2s. 2 into 2 into 2 into 2. So you all have studied last year. Fourth root of 2 raised to 4 we are getting. When the power and the root is the same, it gets neutralized, gets removed, and you get 2 outside. Okay. So the fourth root of 16, condition is not satisfied. It's getting removed. The root sign is getting removed. Okay. This is correct. And this is also correct, but this condition, middle one, nth root of a belongs to irrational number, is not getting, that condition is not getting satisfied. So hence it is not an irrational number. So you can first show this working, then you can write fourth root of 16 is not an irrational number. Hence, fourth root of 16 is not a surd. Is it clear? Copy it down. You can write down this in the working column for you to understand whether it's a surd or not a surd. Question number 3. Cube root of 81. Not cube root, sorry. Fifth root of 81. Okay. So what is our first step? Break 81 into factor, because the first condition is satisfied. 81 is a positive rational number. All integers are rational number. But now we want to find out whether nth root of a, that root sign can be removed. Fifth root can be removed. So first break it up into factors. 81. What is the smallest number which goes in 81? 3. How much it goes? 27. Again 3 goes how much? 9. Again 3 goes how much? 3. And again 3 goes 1. So 3 3s are 9, 3s are 27, 3s are 81. So you are getting fifth root of 3 raised to 4. This will not get removed because here it is 4 and here it is 5. If both are 5, power and root are same, then it gets neutralized and it gets removed. The root sign gets removed. Here it will not get removed. So that means this is an irrational number. Okay. So now let us write down fifth root of 81. This condition is satisfied. This is also satisfied. It's an irrational number. The root is not getting removed. And the order 5 belongs to natural number greater than 2. All three conditions are satisfied. So fifth root of 81 is a surd because 81, the radicand 81 is a positive rational number. Second, fifth root of 81, we have seen it doesn't get removed, the root sign. So fifth root of 81 is an irrational number. And the order 5 belongs to the set of natural numbers and it is greater than 2. All three conditions satisfied, therefore it is a surd. Okay, copy it down. Sum number 4th. Root of 256. Very easy. First condition is satisfied. 256 is a positive rational number. But square root of 256. Last year you all have studied square tables, square and square root. You have studied square tables up to 30. Okay. So which square gives you 256? 13 square 169, 14 square 196, 15 square 225, 16 square 256. So this can be removed. Root 256, the root sign gets removed. If it gets removed, the second condition is not satisfied. It's not an irrational number. It's a rational number if it gets removed. So therefore you can write root 256 is not a surd because root 256 is not an irrational number. Fifth one. Cube root of 64. You all have studied cube and cube table also, so you know that 64 is which number's cube. 4 4s are 16, 4s are 64. So 4 cube. So now first condition is satisfied, it's a positive rational number. Second condition is not satisfied because we know 4 cube is 64. And when the order and when the power is same gets removed and it becomes 4. 4 cube root of 64 is 4. Okay. So that means the second condition is not satisfied. It's not an irrational number, it's a rational number. So it is not a surd. Is not an irrational number. Okay, we go to the last sum, sixth one. Sum number 6. Root of 22 upon 7. Okay, now recognize. What can we say here? Inside 22 upon 7, it is a positive rational number. P upon Q form, something upon something, that's a positive rational number. Then root 22 upon 7 can we remove? No, 22 ka factors 2 into 11 and 7 is a prime number, cannot be removed out. So the second condition is also satisfied and the order is 2. So order n belongs to natural number greater than equal to 2. So all the three conditions are satisfied, therefore it is a surd. So you can write down root 22 upon 7 is a surd because first, 22 upon 7 is a positive rational number. Root 22 upon 7 cannot be removed out, the root sign cannot be removed, therefore it is an irrational number. Order 2 is a natural number equal to 2. Write it down. So we have finished one type of sum to recognize whether the given irrational number is a surd and with justification. We have completed that. Now we go to the next topic, simplifying a surd. Simplifying a surd. Okay, this is based on the last when we were doing how to find out whether it's a surd. The same, it is based on that. So let us do this, simplifying a surd. We'll straight away start with the exercise. Fourth question, first one, root 27. Now how to simplify a surd? First you break up this 27 into factors. First break up the radicand into factors. Okay, the steps I'm going to write here to simplify a surd. The first thing, break up the radicand into factors. Second, I'll tell you what this means. Should not have factors of the nth order. We'll see what this means. Second one. Okay. So first, to simplify a surd, first you have to break the radicand into factors. So break it up into factors. What are the factors of 27? 3 goes in 27. How many 3s? 3 3s. 3 into 3 into 3. So this is nothing but square root of 3 raised to 3. Okay. So first of all, let us see what is the order here. If nothing is mentioned, it means it's square root, and we have 2 3s here. Okay. So this becomes, we can write 3 root square into 3. This can be removed out because here root and the power is same. So that is what we mean by radicand should not have factors of the nth order. So the order is 2. So the factors power should also, if it is 2, it should be removed out. So when you remove this out, it gets simplified. Now our surd is simplified. Root 27 is simplified to 3 root 3. Have you understood how to simplify a surd? Break up the radicand into factors. Follow the rules. Break up the radicand into factors. Then you just go and find out, just observe the order. What is the order? 2. So inside 2 power should not be there. Now here 3 into 3 is 3 square and one more 3 is there. So you can remove this 3 square out. Okay, when the root and the order is same, root and the power is same, you can remove it out. So 3 gets removed and this lone 3 gets, irrational number 3 remains here. So it is simplified into 3 root 3. So now we have satisfied both the condition. Radicand should not have factors of the nth order. So now it will become more clear when we continue doing one sum after another. Second sum is 50. Root 50. So how to simplify it? What is the first condition? Break up the radicand into factors. So 50, let us break up into factors. Smallest number which goes in 50, 2. 2 goes how much? 25. Then 2 does not go, 3 does not go, 5 goes. 5 5s are 25. Again 5 goes 1. So you get square root of 2 into 5 into 5. What is the order? 2. So we can see here 5 is got power 2. That we can remove out. When the root and the power is the same, it gets neutralized and it comes outside. So you get 5 root 2. So now this is simplified. Root 50 is equal to 5 root 2. So we have done both the condition. First we broke into factors. Then we saw the radicand does not have factors of the n. Should not have factors of the nth order. It had here. We removed it outside. It became simplified. Now I am sure it might be more clear now. So now we go to the third sum. It will be even more clear. Third. Square root of 250. Let us break this into factors first. Because our first step is break the radicand into factors. Which is the smallest number which goes in 250? It's ending in 0. Of course, test of divisibility says 2 will go. 2 goes how much? 125. Now next 2 will not go, 3 will not go. 5 plus 2, 7 plus 1, 8. 3 will not go. 5 will go. 5 goes how much? 5 2s are 10. 5 5s are 25. Yes. Now again 5 goes, 5 5s are 25 and 5 1s are 5. So the factors of 250 are 2 into 5 into 5 into 5. What is the order? 2. Anything which is repeated 2 times? Yes, 5 is repeated 2 times. So that can come out. This will come out. First I'll write it like this. 5 square into 5. This will come out because square root and power same. So 5 will come out and inside 2 into 5, that is 10. So our root 250 is simplified to 5 root 10. Clear? Write it down. root 112. First we'll break this into factors. 2 goes in this 28, 2 goes in this 14, 2 goes in this 7 and 7 ones are. Write down. How many 2s are there? 1, 2, 3, 4 2s. 2 into 2 into 2 into 2 into 7. Okay, so the first condition, we broke up the radicand into factors. Now next is radicand should not have factors of the nth order. What is the order here? 2. So anything which is repeated 2 times will come out. Here one more 2 is repeated 2 times. So you get 4 root 7. So root 112 is simplified to 4 root 7. Have you understood? Yes. Last sum, root of 168. Let us do that sum. Root of 168. What are the factors of 168? It's ending in 8. So 2 will go, 2 8s are 16, 2 4s are 8. Again 2 will go, 2 4s are 8, 2 2s are 4. Again 2 will go, 21. Now 2 will not go, 3 will go. 3 7s are and 7 1s are. So write down the factors inside. 2 into 2 into 2 into 3 into 7. Okay, so first we have done. Now second one, radicand should not have factors of nth order. What is the order here? 2. So one which is repeated 2 times will come out. Nothing is repeated here. Here only 2 is once 2 is repeated. And then 2 3s are 6 7s are 42. So root 168 is equal to 2 root 42. A simplified form. So we have finished simplifying a surd. So today we completed what is a surd. We recognize the parts of a surd. We have seen how to identify a surd and how we simplify a surd. Okay, so students, practice set 2.2 is omitted. I'll write it down here. Practice set 2.2 is omitted. Okay. So what you have to do is you have to write down each and every sum done today. Okay, for homework. Practice it in your rough book 2-3 times till you master the steps. And I'm not giving you any sum from problems at homework. I'll do it because it's a little tough. So we'll do it when we were doing the problem set. Okay. Thank you.